Here's a little something I thought you might find interesting. I picked this speaker up attached to this round plastic thing at a flea market today for $1. It's an 8-inch speaker, permanent magnet, and I thought I'd measure and see what what value, what impedance the speaker was. So we'll hook up our multimeter to one wire here, which goes down and connects to there. This black wire here goes down and connects to there. Then the red wire comes out. We'll go ahead and connect the other lead of our multimeter to it. I can get it to quiet down here long enough to do it. Let's see what kind of reading we get. Well, I was kind of hoping this thing would be like a 6 or an 8 ohm speaker, but it looks like it's less than 1 ohm. Less than 1 ohm. I'll tell you what, let's go ahead and take another reading of this speaker. If I can get this wire to quiet down again. And you just kind of keep your eye on the multimeter. Remember last time it was less than 1 ohm. I'm going to hook up the alligator wire. Here we go. 7.9 ohms. Now, what was the difference between the last time I hooked up the wire and this time I hooked up the wire? The last time I hooked up the multimeter to the speaker, this wire right here was connected to that terminal right there. Let me zoom in a little bit here so you can get a better look at it. This wire here was connected right there. It was soldered up. I have since unsoldered it. Now I'm taking the black wire, which is also soldered to that same spot. Let me get my pencil here. That black wire soldered to that same spot right there where that wire was. And I've again, got it hooked with the alligator clip. And then, of course, the red one I never touched. It's still connected with an alligator clip to my multimeter. And I took the reading, and that's why we got the 7.9 ohms, because this wire was disconnected. But so what? So what if that wire was disconnected? Well, I'll tell you what was happening. Electricity takes the path of least resistance, okay? And what was happening was the voltage from the battery in the multimeter, when you use when you're testing resistance, the battery comes into play. Anyway, the battery voltage was coming down this wire, and it was going out, and instead of going through the coil, the voice coil down inside here in the speaker, what it was doing was taking the path of least resistance, and it was going up this wire right here and going through the secondary on this audio output transformer right here, which was less resistance than the voice coil. So it went this way through here and then out down this wire over to here and then up this red wire into the multimeter there. So once I disconnected it, that path was no longer available. So now I have the connection directly there and directly there to my multimeter, and I'm now reading through the voice coil. Now, why am I showing you this? Well, I'll tell you. Well, a couple of videos ago, Gordon Cole, our good subscriber, he said, if you lift R1 on one end and isolate it, you may get more of a correct reading on it. Well, I, of course, showed him later on in the following video that it's already isolated. But what he was trying to get at is exactly what I showed you on that speaker. If you have a coil or another resistor that's in parallel with this thing, then anywhere in the circuit, it could be way over here, it could be way down in here somewhere. It could be a coil. It could wind up going through a coil like this or something. And what would happen is you would get an incorrect reading. So in that case, you would need to go ahead and isolate the resistor. So he made a very good point there, and I just wanted to show what he was talking about, a little demonstration of it. Okay, you always have to follow your wires out, your lines out, to make sure that doesn't happen. Okay, I'll tell you what, let's go ahead and try to finish up with this corner here. I'm getting kind of sick of looking at it, to tell you the truth. I want to get it over with so we can move into some other area of the schematic. So I'll tell you what we're going to do. Today we're going to chase down the wires that connect to both sides of our tuning meter. The tuning meter sits up on top of the chassis. You all saw what that looked like when I first got the radio. And we need to find these two wires. I have no idea where they're at. And a couple more wires. This one right here is another wire we need to find. And here's one right here. No, that's the tuning. Here's one right here. Okay. Let's see what we can do with that. Alright, for those of you who have kept up with this wire chasing ordeal from the beginning, this is just going to be, old news to you, old hat, same old drill. For those that are new here, it would be best for you to go back and start from the beginning, part 1, and work your way down through so you know exactly what we've been doing. Anyway, well, like I said, we're going to find the wires that go to each side of this tuning meter. Now, one wire comes over, it comes out of the plate. Get a little closer here to help you out. Comes out of the plate of the 35 to the IF amp, 35 tube. Pin 2 goes down through the coil, all the way down to one side of the tuning meter. Now I've already got a multimeter lead connected to pin 2 of that IF amp tube. It's right here. Okay. That's pin 1, pin 2. We'll go ahead and connect it. Now what we've got to do is we have a bunch of wires that are just dangling here, hanging out in the middle of nowhere. And most people would say, oh, what a mess. I have no idea where this stuff goes. Well, we do. We know exactly where it goes. One of the wires goes to pin 2 on the IF amp tube. Right there. One of those wires go there. And when we find it, it'll be one less piece of spaghetti we have to worry about. So what we have to do now is we have to take, now I've stripped off the ends off of almost every one of these wires on this side over here. I just stripped them back, maybe a 1/4 of an inch with my strippers. So what we're going to do is we're going to go from wire to wire. Let me back up here so you can kind of watch the multimeter. We're just going to go from wire to wire and hopefully we can keep track. Alright, I'll tell you what, let's just start with this one right here. Here's one right here. See if we get any continuity between here and the wire. Here we go. Nothing there. Alright. Nothing there. Nothing here. Nothing there. Nothing up my sleeves. Okay, here's another one down at the bottom. Let's touch this one. Nothing there. Here's another one. Nothing there. We're running out of wires, people. Something better pop pretty soon. Here's another one right here. Still nothing. Uh-oh. There's another one. Oh, man, I hope that wire's not missing. That would be terrible. I think we already checked this one just to be sure. All right, we're back to this one here. Last one in this area anyway. Ho, 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 we got lucky. There it was, the last wire. You know, that's always the way it is, you know. You know, when you lose something, it's always in the last place you look. How many times have you heard someone say that? Do you know why it's always in the last place you look? Because you don't look anymore. You found it. Okay, here we go. Just to make sure. There it is. All right, that's all I'm going to do. It says tune meter. I'm going to stick it right around that wire right there. I also decided to go ahead and write IF on that because one of these, now this wire that we just ohmed out here, one of them comes from the IF, which would be the right hand side of the meter. And I don't know, once we get up in there, we may have to hook it up to that particular side. I don't know. You know, just to be on the safe side. It doesn't hurt to mark which one the wire came from. In this case, the IF tube right there. Okay, now the next side of that meter, let me back up here a little bit. The other side of that meter, again, goes up through a coil. Interesting thing here, look at the length of that coil compared to these over here. It would seem to me that would have a lot higher resistance than say something like this. We're about to find out, I guess. We come out of the meter, we go up through the coil to plate 2 of the RF amp. I mean pin 2, which is the plate of the RF amp. Alright, let's look at the, let me get this out of the way again. Let's go ahead and disconnect it here. This is the RF amp tube up here at the top, pin 1, pin 2. We'll connect that. Now what's happening here is the wire coming off of that pin. Make sure you get a little clarity here. Zoom in. The wire coming off that pin goes over to the coil. It goes up through the coil and comes back out. That's exactly what's happened here. It's coming from the plate of the RF tube. It's going up through the coil and back out. And then it goes down to the meter, just like it did over here. It came up to the coil, went through the coil, came back out the coil, and went over to this side. Piece of cake, guys. Piece of cake. Alright, let's see if we can find that little booger. Alright, we've got our meter hooked up. Same procedure as last time. Just start probing around till we find something. And we'll start with this one. Let me get the meter over here. We can take a look at it. Looking for continuity here. Nothing there. Nothing there. Let's see, we got a few more down here. We'll get there. Let's get these over here first. This one here. This one here is not connected to anything. Let's go ahead and check it while we're there. Nothing there. Oh, there we go. We found it already. Alrighty, tidy. Okay, so here's what's happening. This is coming off that tube pin, going up through the coil, coming back out. It's going up into the coil through this pin right here. Zoom in. I want all of our young folks to see this. This is very important so you know what you're doing when you look at this stuff. It goes into the pin here, into the coil on this pin here. It comes out of the coil right here. Then we follow it down, and here is where it hooked on to. And like I said, look at the resistance on that. It is much higher than I normally would find. Normally I'd find about 3-4 ohms. That's a lot of resistance there. But of course, you know, it's dealing with the tuning meter, which probably requires, you know, a much higher resistance than say a standard old tuning coil. Okay. All right. Let me go ahead and mark this one right here with a piece of tape, and then we can go ahead and put a piece or we'll mark it with a piece of tape, and then we'll go ahead and color orange up here on our schematic. I have not yet installed this resistor yet, so we're going to go ahead and leave that orange, but we'll get to that. And I won't do it in this video, but I think by the time the next video comes out, we'll have her all done. Now what we have to do is check this line right here. This has not been made orange. And we have to check this line right here. This line has not been made orange. And this line has not been made orange. So let's look at this real quick like. I think we can do this without even hardly batting an eye, without even hardly thinking, all of you who've been paying attention. Now I can go to the top of the chassis and connect onto the grid cap right here, the grid cap connector of this RF tube. And it would read me all the way down through the coil, through the straight wire we put in there now, and then on out. Well, why go through all that? Why don't we just come over here and connect right here where the capacitor, one side's ground, the other side's connected to the coil. Let's just go ahead and hook our multimeter there. Then it'll read down through this line, I mean this straight wire I put in. It'll come over, and I should be able to come up here and read to the one side of the second capacitor that's connected to ground. And if I get a continuity reading between those two, then that means both of those lines are good, because we know everything else is good, okay? All right. Now what capacitors am I talking about? Let's go ahead and tip this right here. Tip it up a little bit. I'm talking about the two yellow ones. Let me get my pencil here. Got to have my pencil. Now one side of this capacitor hooks to ground, right there. One side of this capacitor hooks to ground, right there. So we're talking about this side of the capacitor here, and we're talking about this side of the capacitor here. I should have continuity between those two if everything is good. So let's go ahead and hook our multimeter to one side, and we will touch our lead to the other side of the second cap. Touch. There we go. There we go. We have continuity, people. Continuity has been established. Alright, what that means is this wire is good across up to this capacitor, and this wire here is good. So I just colored it in with orange. Now we have to come across and see. Now this one right here is going to be a little bit of a problem because we're going to probably have to go to the top. No, we might be able to find out the bottom of the coil. Let me see if I can find out where it comes out of that coil right there on the IF amp. Okay, here's the way we're going to attack this one. Again, we want to make it simple. Simple and easy. Simple and easy. Always look, if you see one way of doing it, always look for a second way that might be easier. Now what we're going to do is we're going to measure from the grid cap. We're going to have to go to the top of the chassis for that. On this IF amp, we're going to measure down through the coil, on down, and then we're going to come all the way down here and connect to pin 2 on the AVC tube, the number 24. Okay? Now I have already connected right here to pin 2. This is your AVC tube. I have it marked right there, AVC. And this is pin 1, pin 2. I'm going to connect pin 2 right there. Bam. Okay, now we'll lower it down. This is the grid cap on the IF amp. We're going to go ahead and touch this. Keep your eye on the meter. And if we have continuity on this, we're just about ready to wrap up this particular video. Here we go. And there it is. We do have continuity. Okay? Alright. I think that's just about it for today. Now what I'm going to do, like I said, is I'm going to go ahead and replace this resistor next time. But meanwhile, let's go ahead and color this in. Oh, I like doing this. Alright. Oh my goodness, I just found one more wire. Oh, shucks. One more wire. Well, I'll tell you what. I think what we'll do is we'll find this wire here next time. I'll have the resistor in here. We can color it. We'll find this one wire and then move. Okay? Anyway, until then, this is John. By the way, this quiet power switch right here, it'll be coming off the quiet power switch. The wire we'll be looking for, which is, this is your quiet power switch. I'll tell you what, this stuff's getting easier by the moment. Easier by the moment. Okay, that's it, my friends. We've got a lot more to go, but that's the status as of this moment.